All right, now it is time. So first we have completed our node class. It is a generic node class where you can create any type of node. You can have strings, integers, cars, whatever Java objects can do. And now we have our singly linked list. Head, constructor is done, insert front, and print is done. This is our runner code. This is how we run the program. The thing about linked list is that it's a flexible data structure. You can insert literally anywhere. If this is the linked list right over here, we can insert in front of the head. We can insert over here to the end, like after 1, instead of null, you can put like a 5, and then null. We can literally even like insert elements into the middle, like 7, something like that. This is a perfectly valid singly linked list. So we can do that. Public void insert or instead of insert behind, we can say insert end. The thing is, so this is just a pointer to a node, and this node happens to be the head of the node, you know. So if I wanted, so in this code over here, insert front, we change the head to mean another node. When we insert this node 3, which points to null, we change our head to mean 3, and then next becomes 1. So this is just a pointer. It can be anything. And if we wanted to insert to the end of a linked list, we would either have to traverse the whole linked list like many times. Let's say insert, okay, let's just write an example. So this is our linked list, and we have to insert a 10. So this is our node. We could either traverse the whole thing. So it'll go 3 if it's not null, 1, not null, 2, next, 4, next, 1, 5, 1, 5, next, and then it'll go 10 to null. Or we can just save another pointer which has the end. So every time we would have to run this function, it would just be O of n. This would be O of n without a pointer to the end node. So let's just create an end node. Or okay, head, tail. Let's make it tail. So now we have node tail. This dot head is head. This dot tail okay, how do we do this? Actually, this is a good exercise because this dot tail is head. Well, yeah, when you first create the linked list, yes, this dot tail becomes head. Insert to the front. Wait, no. This is wrong. Okay, so this is wrong. So when we create a node, it points to null. So tail is null. That's a good point. Okay, so we have tail is null. Insert to the front. Okay, this begs us to find public node. So this is a T set tail. What am I doing? Node T current is equal to new node. Oh, no, okay. I am not thinking. Okay, so basically set tail. Every time we add or... So I'm guessing, okay, so let's think. This function will need to be run every time changes to end. That's no. Run once to find the tail. We want to run this only once. We don't want to have to set it every time. So is this dot head? Let me first write it out. While current is not null, current is equal to current dot get next private method, yes, not private method, private instance variable. We can just make this void, so set tail. While current is not null, this dot tail is equal to current. Current is equal to current dot get next. So when current is null, it won't go here. Okay, so I like this. So we do ll dot. So okay, now we're gonna test it. Let us first do, okay, this is fine. Set tail, public void set tail. Okay, autocomplete set tail. We have 0 parameters here, and okay, should we create a getter and setter? Or we can just, okay, for this purpose, also, one more thing. So, in the node class, I forgot. So, over here, we're now trying to print out like an instance variable of LinkedList, right? So, LinkedList.tail. I don't know why it came here. Get next. This is fine. No. So ll.tail. I'm guessing this will be some like gibberish. I mean, I'm pretty sure it is. It's an object. We have set the tail, but it's going to be gibberish. Yeah, node.node at 5e265ba4. Okay, this literally means nothing, but node.node means that it's an object of package node and class node. So what this print, so the whole point of this was that we don't have a system.out like a toString, public toString for a node. So this is a node and we don't have a toString for that. So we go to the class node.node, node.node, and we don't have a public toString. So this is a method. Okay, so multiple markers at this line. Overrides Java lang object toString. This is a method that is created with every object toString. If you don't write your own toString, it'll do something like this. But if you want it to print something, you should probably do something like public string toString and then return something. So we have a node of t value. How do we want to print this? This dot get value plus \t means tab. Let's see how this looks. So 3, 1, 2 comes from here. Run again. So the tail is 2. Okay, the tab may be a bit excessive, but same thing. So we now have a tail node. So in the set tail function, it takes O of n time, where n is the size of the linked list. Size of the linked list. That reminds me, we should do a size. Size, length, whatever. Okay, so now we have set tail. Now we have tail. We only have to do it once. Now, the thing is, okay, so this is our linked list, 1, 2, and null. Let us work with this one. Now we have to, let's say we have to add 3 to the end of this linked list. To do that, we first create a node. That becomes 3 points to null. That's fine. Now we don't change the pointer here. We change so the pointer here is fine because if it goes to the end, it should be null. Now we have to change the pointer of the tail here. So this should be the tail 2, which points to null. So our code should do 1. Okay, so tail, find tail, which it should be done, and then we have tail. Now we do 1 points to 2, and now we change the pointer of tail and make it point to this. That is how we would add to the end. Therefore, again, t value as parameter. We can create the node within the function as we do now. T node is equal to new. Why do I new node value? Okay. Another quick thing to mention is that we set the tail in the runner function. So given the API, so this is an API idea where you give this to people to use for their own applications. They can use it for strings, horses, whatever. So, however, these people need to know that they need to set the tail at least once. Because otherwise, otherwise tail is null. So if they create a node, like a singly linked list node, like this. So it's 1 which points to null. Head is 1 which points to null, but tail is null because, it's the tail. So it has to be noted somewhere that if this dot tail is equal to null, we need to run set tail. So that tail is not null. It'll find the last one and make tail not null essentially. Now onwards. So we've done this step. Well, we've done this step. Now we found the tail. We found that's our third step. The last step is to change. So this dot tail dot set next node. That's it, right? Set next. Okay, set next has to be void, yes. Yeah, that's it. So O of n without a pointer to the end node, O of 1 if tail is already initialized. All right, so now we have 312. 312, tail is 2. LL dot, what's the function name? Insert end. Dot insert end 6. Oh, we didn't print. Never mind. Print. And to avoid any other confusions, let's just do this. Tail is 2. 3, 1, 2, and then after that we add 6. Okay. Okay, let me just do something. System.out.print. This doesn't look like a very pretty linked list. So let's do current.value And then, okay, so now current is null. Print line. Null. Okay. Okay, this makes sense now. Okay, so essentially what I changed is system.out.print line. ln means line. So at the end of this, it'll just go to a new line. However, if I do system.out.print, it just stays in the current line. Now it looks like an actual linked list, which is good. There's an extra space. 3126 null. Set tail. We don't need this statement. 3126 null. Awesome. Insert front. Insert. Okay, the thing is we can also do an insert after. So public void insert end, insert front, insert after like a specific node. Like, okay, so it'll look through. Let's say we do insert after node 2. So we could do that, but the thing is we can add duplicates. So we can do this. We can insert duplicates. Whoa, what happened here? Insert end. Oh, you know what? Okay, there's a minor bug here. I get it. So the problem here is that our set tail is managed by the user. I think maybe it's a better idea to make set tail private. Because, okay, if we look at the current code, insert end, right? Node value. So we do, if tail is null, we do set tail. So we account for the user's error there, but we don't account for if they add something else to the end. See, we add 6 and then another 6. There is no accounting for if the user just adds multiple ends. So that is an error. So that's why you don't see 2 6s here, which I wanted to happen. So now we need to change insert end a bit. So if tail is null, that means we have to set tail. We have to go through the whole LL to find tail. Else, we already have a tail here. Actually, okay, let's just make this simple. This is just, what am I, okay. Okay, so this is O of n the whole way. To make things simple, like easy code wise, set tail. We don't question that it's null or not. We just assume that it's not set properly, and then we use set tail to go through the linked list and find tail, and then we just set next. So every time we insert to the end, we run through the whole shebang. It's kind of inefficient. So that is an easy solution to our problems. However, I kind of liked it like this. If tail is equal to null, this dot tail is null, then set tail. Okay, we have to think this one through. So, okay. 1, 2. Okay, that's enough. No. So let's just assume that 3 is tail. We do set tail here, and so 3 is our null. 3 which points to null is our tail. So this dot tail I think I found a better solution to our woes. Huh. Awesome. Okay. Okay, now time to explain the thought process. So, insert end. So, I was thinking we should do something like this, right? So if tail is null, we set tail. So tail is being set, and then we would do something else here, right? What the hell? Like some gibberish. But we don't need that because the only issue here is that we don't set the tail at